Let me show you something interesting. Two companies report their average salary. Company A, 50,000 pound. Company B, again 50,000 pound. Same average. So they are equal, right? Not really. Because in company A, almost everyone earns around 50,000 pound. But in company B, most people earn 20,000 pound and a few earn 2 lakh pound. Same average. Completely different reality. And that difference comes from something called distribution. Because data is not just about what average is, it is about how data is spread. And that is exactly what we are going to understand today. Welcome back to Shital's Data Desk. I'm Shital, and in this video, we are going to cover what distribution really is. We will explore normal distribution and skewed data and how it destroys reality. Then, variability, what truly shows consistency and risk. We will also cover how to measure it using range, variance, and standard deviation. Then we will connect all this to real world decision making and we will bring everything together into one big insight. So, let's start with the foundation. What exactly is distribution? How data values are spread across possible outcomes. In simpler terms, it tells us where most values lie, how frequently values occur, how spread out data is, and whether extreme values exist. Think of a distribution as overall pattern of your data. If you plotted every value on graph, shapes found by those points would reveal distribution. And understanding that shape helps us answer questions like, is most data clustered together? Is data spread widely apart? Are extreme values common? Is the data balanced or skewed? Without understanding distribution, you are only seeing part of the picture. Now, once you understand what distribution is, next question is, what does good or ideal distribution look like? One of the most famous distributions in statistics is normal distribution, also called bell curve. It has three major properties: symmetric shape, most values cluster near mean, extreme values become increasingly rare. Why is it important? Because many natural and human phenomenon approximate it. Heights, IQ scores, measurement errors, biological traits, and more importantly, many statistical methods assume normality, including confidence intervals, hypothesis tests, regression assumptions. That's why understanding normal distribution is essential. In normal distribution, mean, median, and mode are equal. Everything is balanced. And here's the key intuition. System is stable, no extreme bias, no hidden surprises. So, when data looks like this, analysis becomes easier, predictions become more reliable. But here's the catch. Not all data behaves this nicely. And this is where real world data starts to get interesting. In real life, data is often messy, and this is where skewness comes in. Let's take income as an example. Most people earn moderate salaries, but a few people earn extremely high incomes. This creates right skew, also called positive skew. It means tails extend to right. Extreme high values pull average up. So what happens? Mean becomes misleading. Now flip the situation. Imagine exam scores where most students score high, but a few perform very poorly. This creates left skew, also called negative skew, meaning tails extends to the left. So the key insight is skewness tells you where imbalance is, and more importantly, it tells you when not to trust average. Because in skewed data, average is not equal to typical value. But even that is only part of story. Now, let's talk about something even more important: variability. Because distribution shows shape, but variability shows spread. Let's go back to our earlier example. Two data sets with same average. Dataset A, values are tightly packed. Dataset B, values are widely spread. Same average, very different variability. And that different changes everything. Because Variability tells you how consistent data is, how predictable outcomes are, how much uncertainty exists. Low variability means stable system, predictable results. High variability means uncertain system, risky decisions. So, in real world analysis, variability often matters more than average. So, the natural next question is, how do we actually measure this variability? There are several ways statisticians measure spread. Simplest is range. Range is highest value minus lowest value. It tells us total spread. But range has weakness. It depends only on two values. That means one outlier can distort it heavily. So, statisticians use better measures. Variance. Variance measures how far data points are from average. Larger variance means data is more spread out. Smaller variance means data is more concentrated. Third, standard deviation. Standard deviation simply square root of variance. It is often preferred because it is the same unit as original data, making it easier to interpret. Standard deviation also measures how far values are from average. If most values are close, low standard deviation. If values are spread out, high standard deviation. Now, why does this matter? Because it directly impacts decisions. Let's take example. Let's consider two investments. Both return 10% on average, but one has stable return, other has huge ups and downs. Which one would you trust? One with lower variability. So standard deviation is not just a number, it is a measure of risk. And this is exactly why all of this matters in real world. Let's connect everything. In business, people often say average increased, but that's not enough. You need to ask, did variability increase? Is data skewed? Is the improvement consistent? Because small average increase with low variability is more valuable than large average increase with high variability. This applies to marketing campaigns, product performance, financial returns, A/B testing, because in real life, decisions are made on consistency and reliability, not just averages. Here's the big idea. Distribution shows pattern, variability shows stability, and together they tell you how much you can trust data. Without distribution, you miss shape. Without variability, you miss risk. And if you ignore both, you risk making completely wrong decisions. And this leads to final takeaway I want you to remember. An average is just a number. A distribution is the reality behind that number. So next time you see data, don't stop at what is the average. Ask, how is it spread? How consistent is it? Because that is the difference between reading data and understanding data. If this change how you think, don't forget to like, share and subscribe to Shital's Data Desk. Thanks for watching and I'll see you in next video.